Hello. Today we're going to be doing the matrices, or at least the basic ones. It looks complicated, but it's not. It's basic ones. But when you get something like that, end game is to make something looking like that. That's the end game idea. You want the 1, 0, 0, 1. These are called pivot points. These are called pivot points. Which you get to show point matrices if you ever get to that point. It's in linear algebra. And these are like little zeros, the free variables. And these are like the answers you get out of it. Uses of matrices is you deal with it helps you with systematic equations. Yeah, you can use substitution methods, but that can be annoying except for maybe most people. So let's start off with the basic method of it. First method you do matrices, multiply or divide a row by non-zero value. For example, you get this matrix. You can know the 1/3 part right there. You multiply it by a third, which is probably gonna be easier to try to do. You get 1, 3, 2, 1. Multiply that by 3, you get 6. You get 3, and that's one way of dealing with the row is multiply or divide row by the non-zero value. You can't make the whole thing 0. Second method I'll show you on there. Replace a row or column. Basically, with this, again, this is an example. I'm doing it as quickly as possible. You got 2 right there. Obviously, you get that. You multiply everything from top row and bottom row. If you don't understand that, I'm sorry about that. I might be going too fast or whatever, but you got the second one. You got 2 and 1, and you do O2 minus 2O1. And before you panic, it means row. O2 is short for row 2. O2 equals row 2. O1 equals O1. This is row 1. And this is row 2. And yeah, it looks intimidating at first, but if you do multiply them, you get it or whatever. Just practice with that. You know, I kind of hated doing that when I was like that, but you get R2 minus R1. You replace row column with multiple Veneto row column, which is the second method, which is applied. But you end up getting, knowing how this is going to end up working, 0, 3 times, or 1 minus -5, 3 minus 12, okay, will be -9, 6, and then the top row stays the same. And looks like you don't have to interchange as much. But interchanging is literally you put it all to the top and all 1. But again, you want to game like that, it won't be a good idea. But for example reasons, this is interchanging the row. And this is what you get. Get when you interchange the row. Now here's the fun part. How is it used and applied? Which, again, okay, if you don't know about it, you can just simply use. If you have this kind of calculator, you can use little press. Second system solver. You gotta use 1, and it gives you like this basic systematic equations, or you can do matrices on there. What call matrix can do that, but first thing you do with this, now you've been tempted to try to use substitution method. That's correct too, but this is like a quicker way where you learn in linear algebra. They put it in matrices. 1, -2, -2. And the end game is this. So what I can do, interchange a row, not gonna write. Basically, if this is row 2, consider this is O2, row 2, O1, row 1, because we're lazy and we don't like to write the whole thing. How you do this is you put row 2 at the top, row 1 at the bottom, and because you're interchanging, you're not doing much about it. Negative 2, negative 2, 2, 1, 2, 1, 4. And now you get O2 minus 2O1, and ideally you get 0 right there. O2 minus 2O1, that's 4, that ends up being 5, and then 4 minus, or that ends up being 8, negative 2, the 1 stays the same. These are like little outcomes you get, and then the top one, you try to get rid of negative 2, so O1 minus, how do I make that 0? I just simply do negative 2 over 5, or 5 times negative 2 over 5, which is negative 2, O1 minus 2 over 5, O2, and now you get 1, 0. Fortunately, you have to do that same with that. So negative 2 minus negative 2 over 5 times 8, and you get 0, 5, 6 over 5, and you get negative 2 minus negative minus negative 2 over 5 to the 2 to the negative 2 end up being okay, I hate this part of the problem. Ideally, use a little word text. This is embarrassing. Not gonna bother editing because walk through this. You get R1 minus, okay, negative 2 minus 5 times negative 2 over 5, and you get 0. So now you get negative 2 minus 8 times negative 2 over 5, and then you get 6 over 5. So yeah, you get 0. You get, okay, on the right track, you get 1, 0, 6 over 5, and then the bottom stays the same. You don't have to do much about that one, but now I have to get rid of 5. You can just simply divide by 5, O2. At the bottom, you get 1, 0, 0, 1, and then you get 6 over 5 and 8 over 5 as the answers, or ideally. And when you're checking that, you plug it in, the equation. 2 times, top one is x, so 6 over 5 plus 8 over 5. Plug it in the calculator. 6 over 5 plus 8 over 5. And you get 4. And for the second one, 6 over 5 minus 2 times 8 over 5 equals 6 over 5 minus 2 times 8 over 5. And you get negative 2. And you got your answers with that. So now you got x equals 6 over 5, y equals 8 over 5, and this is your final answer. And plug it in a calculator and you magically get it. And I made a video over 5 minutes. And this is the final answer right there.